Hi! Today we're going to learn about the binomial theorem. So let's say we have a problem like this. When rolling a dice, what is the probability that 3 out of 5 rolls results in a value divisible by 3? So, before we get started, we have to first figure out what are binomial distributions and what a binomial setting is. So, let's start with the binomial setting, and hopefully then binomial distributions, or binomial variables, will come into play, or come into our understanding. So what is a binomial setting? Well, binomial settings are just the 4 conditions that must be met for a variable to be called a binomial variable. So let's go over them. The binomial settings are binomial setting. So the first condition is that the trials are independent. So what does this mean? Well, this means that for each trial, the values or the results of the previous trial don't influence the results of the next trial. So every trial is independent. An example of this is flipping a coin. If you get 3 heads in a row, that does not change the probability of getting heads on the 4th time. It's still 1/2 if it's an equally weighted coin. The next condition is that the probability, and I'm just going to say prob for short, the probability of a success is the same for each trial. So once again, this and this condition and the first condition are very similar. So what this one says, the first one says that the trials don't influence each other. The second one says that the probability of a success, or the probability of one outcome, remains the same for each trial. So once again, we can look back at this coin example. In the coin example, the probability of getting a head is 1/2. And for it to meet the second condition, for every trial, we must have a probability of 1/2 of getting a head. So basically, for each trial, the probability of a success or the probability of an event occurring is the same. Now the third step, or the third condition, says there are only 2 outcomes. There are only 2 outcomes. Let me get down here. There are only 2 outcomes. A success and a failure. A success or failure. Whoops, making so many mistakes. A success or failure. So this does not mean literal success or failures. The key term here is that there are only 2 outcomes. And the outcome, or the event that you're trying to find the probability of, or that you have the probability of, for example, okay, so let's take a parallel example. Let's say we have the coin example. And let's say we want to flip it 4 times. And up arrows for or just heads and tails. So let's say that we get H, T, H, and T. So heads, tails, heads, tails. So if we wanted to find the probability that 2 out of these 4 times the coin would land on head, then heads would be the success and tails would be the failure. So basically, whatever you're trying to find the probability of is the success, and the other, or the other value that it can take, or the other, or its complement, is the failure. So really, the key thing here is that there are only 2 outcomes. So there can't be 3 or 4, otherwise it cannot be a binomial variable, and that's where we get the word binomial variable from. There are only 2 outcomes. and then the last condition. And this is what separates this from a geometric variable. So this last outcome, or this last condition says x is equal to the number of successes. So x is equal to the number of successes. Okay, so now that we have these four down, take the time now to write this into your notes. If you haven't done so already, just pause the video and do that. Okay, so now on to the binomial theorem. So, what does the binomial theorem say? Well, the binomial theorem is, it says that the probability that x equals k is equal to n choose k multiplied by the probability of a success to the kth power times 1 minus the probability of a success to the n minus k power. Okay, so this looks confusing, so let's just break it down. So let's start here on the left-hand side. We're trying to find the probability that x is equal to k. So what does this say? Well, let's look at our example up here. We want to find the probability that 3 out of 5 rolls results in a value divisible by 3. So the key thing here is 3 out of 5 rolls. Here, we want to find the probability that 3 of these rolls results in a value divisible by 3. So 3 is what k is. So the probability of the amount, so this amount that you're trying to figure out the probability of happening. So k is the number of instances of success you want to find the probability of. N is the total number of trials that are happening, so 5 trials. You want to find the probability of 3 successes, so k is the number of successes you want to find the probability of, and n is the number of trials you want to have. Okay, so now let's break down what we have here. So, here we have the combination of n choose k. Simple as that. The next thing is we have the probability of a success. So, let's see why we want to have the probability of a success, probability of a success to the kth power. So let's say you want the probability of a success, and you want it to, and we know that k is the number of successes that we have. So to find the probability that you have this many successes, you have to do p times p times p, k number of times. And so this, let's say there were 3 in this case, let's say k was 3, this would just become p to the 3rd power. So the rule applies that you're multiplying p with itself k times, so you get p to the kth power. Now let's move on to the last part. 1 minus p to the n minus k power. This is very similar to what happened over here. It's simple. So we know that there are only 2 values that this can take. So that means that the probability of a failure is 1 minus the probability of a success, because there are no other outcomes that can happen. So here we have the probability of a failure. Now we just have to multiply this to the number of failures that we have. So if we have k successes and n total trials, then that means that n minus k, which is the remaining trials, so the trials that were not successes, which are failures. So we have the probability of a failure to the power of the number of failures. So that's all this is saying. This is the binomial theorem. Now let's look at this in action with our problem. In addition to this, we're going to have to know the formula for a combination, because I don't have my calculator with me. The formula for a combination is you have n choose k, or nck, is equal to n factorial over k factorial times n minus k factorial in the denominator. Okay, so let's get started. So let's start with the left-hand side. We want to find the probability that 3 out of 5 rolls results in a value divisible by 3. So our success is when the value is divisible by 3. So we want to find the probability of 3 successes happening. So we have the probability that x, which is the number of successes, is equal to 3. So we want to find the probability that there are 3 successes. And so let's do this. We have the total number of trials, or n, which is 5, choose 3, which is k, multiplied by p, we don't know that yet, to the kth power, so 3 power, multiplied by 1 minus this k, or 1 minus this probability of a success, we don't know that yet, to the n minus k, or 5 minus 3, which is 2 power. So now let's figure out these probabilities. So what is the probability of a success? Well, this is simple. We know when rolling a dice, we can get 1, 2, 3, 4, 5, and 6. And the success is when a value is divisible by 3. So let's just cross out all the values that are not divisible by 3. This is not, this is not, this is not, and this is not. So the probability that the value is divisible by 3 is 2/6, or 1/3. Let me write that so you can see. So the probability is 1/3. Okay, so this is the probability of a success. So let's write this over here. Let's actually move to a different spot. So the probability of a success, P of S, is equal to 1/3. And so that means that the probability of a failure, which is equal to P of S, or 1 minus P of S, is equal to 2/3. Okay, so take a moment to copy this down in your notes because it'll soon be erased. So the probability of a success is 1/3. We'll write that over here. The probability of a failure, which goes here, is 2/3. So 2/3 squared. Okay, so now take a moment to copy all this down because we're running out of space. Okay. So the next thing, or the last step, is to solve for a value. So, excuse me. So, if we had a calculator with us, we could just plug in 5C3. But we don't have a calculator with us, so we're going to have to do this by hand. So, this becomes 5 times 4 times 3 times 2, which is 5 factorial, and we could write times 1, but that's useless, divided by, so we would divide it by 3 times 2, and multiply this denominator by 5 minus 3, which is 2 factorial, or just 2. So 3 times 2 becomes 3 times 2 times 2 becomes 3 times 4. 3 times 4. These will cancel out, and that gives us a value of 10. See, it's not that hard. I should also note that this can also be written as 5C3. So that's another way to write it out. 5C3. Okay, so this is equal to 10 times 1/3 to the third power just becomes 1 over 27, because it's 1 cubed over 3 cubed, which is 1 over 27, multiplied by 4 over 9. Okay, so we get 40 over some value. And once again, I don't have a calculator on me, so we're going to have to solve this out. So you get 180 plus 63. Actually, this becomes 243. But to make sure that we did it right, let's do this on the side. 27 times 9, we get 3, 6 goes here, we get 243. Yes. So we get 243 in our denominator. So the answer to this problem is 40 over 243. But the main thing to take away from the problem is the binomial setting, the binomial theorem, and the formula for a combination. Today we learned about the binomial theorem, and much more. Thanks for watching this video.